reverse. I want to start with the reverse. What we are seeing here, when you talk of the cation adsorption capacity, once the cations adhere around or on the surface of the colloid, we should know that this is reverse acidity. The hydrogen and aluminium cations abound on the surface of the colloid. Are they inside?
No.
Inside is a negative charge. This charge attracts what the positive. So, now, this one is reverse acidity. Reverse acidity occurs when the cations, the hydrogen and aluminium, bound or are attached to the surface of the colloid. Then that acid is what is reverse. And if they are attached here, they are rarely what? Exchanged. They are attached? Are they exchanged? No. We also have the concept of active acidity. And in a situation here, active acidity. They call this one passive. It's passive, but it's not, it's passive. It's reverse. Active acidity. The cations, the hydrogen cations have now what? Dissolved in what? In the solution. What solution are we talking about? The soil water. Remember talking about what cations that are in soil. But what's bound around the particles? All know the soil particle, right? But once the cations are now here, the aluminium, the hydrogen, the aluminium, the hydrogen, they're now inside, dissolved in the solution. That's what we call what? Active acidity. Yes? Reverse acidity, and I said it. It's the result of cation adsorption. Right. How do we give or how do we justify that this one is reverse acidity? The aluminium and hydrogen cations bound or are attached in the surface of what? The particle. But the active one, are they ahead?
No.
They're now what?
Inside.
Inside. A concentrated orange juice, you add water, dissolve. Homogeneous mixture. So now this one dissolved in what? In the solution. What solution are we talking about? We're talking about what? The soil water. So these cations are now part and parcel of what? Of the soil water. Agazang are attached around what? The particle. If I head on the particle, I can mix with what? Soil water. But the active one, now they are part and parcel of the soil water. So the hydrogen solution or hydrogen and aluminium concentration is high in what? In the soil water. So if you look at this, it is now in the solution, not bound in what? In the surface. Okay, we get it now. Right. So hydrogen and aluminium, not only hydrogen, both the cations, aluminium and hydrogen, they are now concentrated where? In the soil solution. What solution are we talking about? Or solvent. What solvent are we talking about is the water in the soil. The information is going to okay. So, now you can assume, or you can now conclude that, okay, reverse acidity is the result of what? Of cation adsorption. But what we see here is, the cations here are not what? Exchanged. Cation can easily exchange here. When these hydrogen and aluminiums are now what? Concentrated in the solution. These ones, I said the cations that are there in the soil, they are not permanently kept, or they are not permanently there. They can be exchanged for somewhat cations. The ones that adheres in the surface of what? Of this particle cannot be what? Easily be exchanged. But once are concentrated in the solution, they can be what? Exchanged. So reverse acidity gives us the concept of cation adsorption. But active acidity, since these cations are now dissolved in water or concentrated, they give us what? The concept of cation exchange. So cations can easily exchange if they are concentrated in what? In the soil solution. What is the soil solution? Water. Water. English, okay, so now it makes sense. Guys, you call us along understand the concept now. Okay. Once the cation adheres, they do not exchange easily. They only exchange when they are concentrated in the soil solution. What is the soil solution talking about? That's water. So now you can tell, oh, say now this thing makes sense. Now, the one that is an influence in growth and productivity of the soil is the cations that are concentrated in the soil. Water. Why? We know that, remember functions of water. Water acts as what? Transport what? Acts as a transport? Now, for these cations are minerals. These cations are nutrients. For these nutrients to be transported from the roots, stem, the leaf directly into the fruit, they need water to be transported. You see that? That's why we want these cations of ours to be concentrated in what? In soil, so that it can be transported in different parts of what? Of the plant. But if the cations adheres in what? The particle, more like what? Hygroscopic water, cannot be utilized by plants. So if the cation adheres, they cannot easily exchange. Therefore, these cations will be there and cannot be utilized by what? By plants. But once are concentrated in the solution, which is water, can easily be what? Used by plants. Since this fan, he adhere on what? On the wall. No man has the way them done the classing. And he has a economist I believe. But Nabang stand can easily get access to it. I remove it from 1.2. But since this one is adhering la yes, you can exchange it, but you cannot easily. The person will remove layer, remember him. But if we fan stand fan, I can easily take it the side and exchange. Do you guys understand that? Why? This one adhering to be la part wall. Now Nalama cations now are adhering on what? On the surface. Therefore, they cannot easily exchange. But Lena is part and parcel of what? Of the solution, which is what? Water. Then water can easily transport it and be used by what? By plants. You understand? Yes. So that's the concept. And they say active acidity. You can see those particles that the cations are inside. This influence plant growth. We have acid. We have acid tolerant plants. This one can still grow even on an acidic soil. We have acid intolerant. This one doesn't want what? Acid. Just imagine now. If that acid, even active, concentrated in soil water, it can be distributed up. This acid can be absorbed by the root hair. Phloem and xylem transport it up. This will damage our plants. That's why we say, That's why we say active acidity has an influence on plant growth. Once this angahamba by different part of the plant, this will inhibit what plant growth. Only if that particular plant is acid intolerant. We have plant that doesn't tolerate acid. Ne? No. We have plants that can grow on an acidic soil. We have plants that cannot grow in an acidic soil. Ne? So this is active acidity. Now the acid cations are concentrated in soil water. And this plant of ours also require what? Water from the soil. And this water has what? A concentration of what? Of aluminium as well as what? Hydrogen. The root hair here will absorb this water. Already the water is what? The what? The xylem up. The what? Stem. From the stem, branches, leaves. And this plant doesn't tolerate what? Acid. Will this plant grow? No. That's why we say active acidity is a type of acid that has an influence on the growth of plants. This one, no. Because these cannot exchange and are used by what? By plants. So, this one influences plant growth by influencing nutrient availability, root development, and slow down microbial activity. Just imagine, we have microbial activities there, like nitrogen fixing bacteria. Microbial activities. So if the soil is too acidic, this will inhibit microbial activity. Same will instill information. If they ask you, what are the negative impact of acid in soil? There's poor root development. It also decreases microbial activities and influence or inhibit plant growth. The plant will die. Negative impact of an acidic soil on plant production. Plant will die. What's that? It will inhibit root development or it will stop root development. It will slow down microbial activity and slow growth of water plants. One general plant die. Single grade 1. Only if that plant is acid intolerant. You follow along on mine. But if that plant tolerates acid, root will develop, right? Microbial activity, they want what? This particular acidic pH and all that.
Growth.
What's obvious? What's the
We read the same thing twice.
well, it's a good. Into yokuqala wena nawufika ekhaya nje net nawufika nje ukuza kwifoni yakho udla ngala ifoni la kapteni ngala updates, daily updates around the world while ungekho wena from whatever time. So you should do that. I'll remind you. What's for enrichment? What are the examples of plant that are acid tolerant? And you go there. You give you that. Polish. You also have to give Polish. Okay, so next, I don't see any reason. Jerry, it's only for this PSK because we did this with chemist. So there's no need. See, I just create 7 is you 0, 7, 14. Very close to 14, strongly acidic.
Yes. Alkaline.
Very strongly what? Very close to 0. It's strongly
Acidic.
after pH 4 to 6.9, it's weak acid. After pH 7 close to 9 and 10, that's weak alkaline. That's the list that I will just give you there. So, let's get deep. Let's dive in the mind. What are the factors that cause soil to be acidic? Remember, you're supposed to causes, impact, solution. Okay? Cause, impact, and solution. What causes an individual soil to be acidic? Some will say, so it's simple, man. Predominance of alkaline, of aluminium and hydrogen. Okay?
Yes.
I don't want that. What is the root cause? That's the acid rain. Yes. They fall on the soil. What will be the pH of the soil?
Acidic.
Huh?
Acidic.
Oh, grade 12. The pH. That's it. Yeah, but the pH in the stomach. That's pH 4. Ufaka i-value naba the pH range. So I should put 2. But if they say give us the pH, we just say what? Acidic. What is the chemical substance that causes the stomach to be acidic? Hydrochloric acid. Marabanga pH range or pH value. Then give us the value. But if they say pH, no. So the first cause of acidity in the soil, say carbonic acid.
Yes.
Say
Yes.
And remember, in the soil we have water, right?
Yes.
We also have microorganisms, right?
Yes.
We also have what? Roots. The roots require oxygen, right?
Yes.
And release carbon
Dioxide.
The microorganisms require oxygen, right?
Yes.
And release carbon
Dioxide.
When the carbon dioxide combines this water, it forms what? Carbonic
Acid.
And the soil pH we want to be acidic. Wow.
Wow.
So now, that's the first cause. The action of the microorganism and the roots during respiration. Carbon dioxide is released, and you also have what? Soil solution, that's water. When the carbon dioxide in the soil and the soil water combine, then we're having a weak acid called what? Carbonic acid. And overall, this will change the pH. This carbonic acid, the acid there will exchange the basic questions that are there. And overall, the soil will be what? Acid. That's cause number 1. The second one, rainwater. Let me demonstrate this. You see this thing is interesting. Mortar. There's a very huge difference between eluviation and leaching. Look, let's say this is the surface from here, subsoil. Going back to soil profile, and we have potassium and sodium, as well as magnesium
And calcium.
and calcium. Overall, this one is basic. Let me
Yes.
add another potassium. We have predominance of what? Of the brackish cations.
Yes.
Overall, this soil is brack. Now, movement. Precipitation. Rainfall into the soil. Seepage. Seepage. Percolation. Then, all of this. And I know we are going to have an argument with some. I know we're going to have an argument with some here. Then suddenly, Sodium, potassium, magnesium, calcium, and potassium leach. They are now here. Only the acidic cations remains there. They got oh. That's not because we don't say that about leach. That's not okay. Once the basic cations leach down into the base of the soil, the pH up there will change. Because we said the pH is determined by the predominance of what of each cation. So if the basic cations are now leached, washed away, even when they're even washed away during what erosion, then the pH of the soil will change. Why? The cations that are required to reverse the acidity are not there. They're actually what? Leached. So we say the rainwater leaches away alkaline ions, not all the ions. And if the alkaline ions leach, overall the acid, the pH will remain not acidic. Now reason I call saying one. Nakamba sodium, potassium, magnesium, calcium are leached. Microorganisms so they release carbon. And there's also water that's in there. The CO2 and the water will combine. You're going to have what?
Carbonic acid.
Acid. We don't have the cations that are there to replace the acid cations that are there. Why? All of these basic cations are washed. Yeah. The third one, when organic matter decays, decaying of yeah, right there. Right there. And do not lean on anything, straight. Now, when organic matter decay, or when dead plants and animal remains decay, that's decomposition. During the process of decomposition, there are acids that are formed. We call these acids organic acids. These are acids that are formed from the decaying of the organic matter. So you should know that now when there is humidification in the soil, then you should know that okay, when the dead plants and animal remains decayed, there are some acids that are formed in there. Those are organic acids, and this will actually create an overall acidic pH in the soil. The same way, uric acid, carbonic acid. You know when the carbon dioxide and the water combines. Even during the process of decomposition, there are organic acids that are formed, and this organic acid contributes to the overall nature or the overall pH of the soil. That's the third cause. The fourth one, if you the overuse of fertilizers, like you add sulfur fertilizers into the soil, this one is acidic. So if you add too much of acidic fertilizer in the soil, this will actually change the overall pH. So if that particular fertilizer of yours, you check on the back, the sulfur, you should know that the pH of the soil here will be acidic. Yeah? And on the mind, even the solution was how are we going to retain, to neutralize the pH of the soil. So adding sulfur fertilizers or fertilizers containing sulfur, this may also cause our soil to be overall acidic. Last, Kumbula is horizon. Kumbula R horizon. We said both of these are parent rock. And if this rock is acid naturally, when it breaks down, it will form soil that is
acidic.
If the parent rock, we say this is the rock in which the soil forms, and that parent rock, let's say the R horizon, is acidic. Once this rock, or let me just say this rock is acidic. Once this rock starts to weathers, We're going to have what? Particles. And the particles will what? Be acidic. When they combine, they form the structure. And that soil of ours will be acidic. In other words, this soil, it comes from a parent that is what? Acidic. That's the point. Angeke mlungu atale umuntu omnyama. Iparent yalomlungu umlungu naye oba mlungu. Same thing applies here. Khona noma yini? Okay. Lenalo. Effects, asset, cause, impact, solution. Already we know the effect. Microbial activity decreases, there's poor root development, and loss of crop yield, or decrease in production, or slow growth in what in plants. If you don't the plant will die. I'm saying okay, effect number 1. Poor root development. Simplify that on your notes. This will cause roots to deteriorate or stop growing. In brackets, poor root development. Oh, I'm making a focus on that back. I'm making senior editor into the poor root development. Loss of crop yield. This one is production. Loss of production. If these were mango plants, what will happen to the yield? It will go down. So it's loss of production. And the plant will fail to absorb water and nutrients if they're exposed to acid. Shows that if the soil is acidic, the roots will be poorly developed. And if the roots are poorly developed, will it absorb water? No. Will it absorb nutrients? No. Like see controller njani. I remember this other one last year. No wonder some people will pressure whatever they're dashing the lime. In lime, neutralize the pH. So how are we going to control, solve, reclaim the productive status of the soil? The soil is overall acidic. There's poor root development, which actually leads to desorption. There's also decrease in microbial activity. Shows this plant of ours is exposed. No wonder yield. Even Jani. Then now we need to reclaim. But back then, the plant was functional, the plant was highly productive and all that. How are we going to reclaim the productive status of this plant? It's simple. You add an agricultural lime. I2. Gunet dolomitic. The calcitic. What is that?